Okay, these are your notes for section 2.7 and 2.8. It's all theorems and postulates that we'll use in proofs that we'll be doing next class, geometric proofs. Now we'll do 2 postulates and then the rest of the theorems on your sheet. Make sure that you're only writing down what we put in the video, because that's all you can have on your theorem and your postulate sheet, and I will check to make sure that's all you've got, so don't put anything else on there. But anything that we write down today, fill in the blanks, make sure you've got the pictures down. All of that can go on your theorem and postulate sheet that you can use on your test. Alright, let's start with postulate 2.9. It is the segment addition postulate, and this is something we already know. We've been dealing with this in chapter 1. It says if B is between A and C, then AB plus BC equals AC. That's our big idea where the 2 smaller pieces add to the whole thing. Now, the second part of that was the first part. The second part of that is the converse of the first part. It says if AB plus BC equals AC, then B is, fill in the blank, between A and C. We've switched the hypothesis and the conclusion around, so it's the converse. Now for our picture, A and C are our endpoints, and B is somewhere inside there, somewhere on that line segment. Okay, it doesn't have to be the exact middle, but it is somewhere between, somewhere in the middle of A and C. And then this postulate says AB plus BC equals AC. Over here I'm going to write 2 smaller parts add to the whole. Okay, and that's the big idea here. Now postulate 2.11 is the same idea. It's another thing we've already talked about. It's the angle addition postulate. Same idea is the segment addition postulate. We're just talking about angles this time. First part of it says if R is in the interior of angle PQS, then the 2 angles it splits it into, the measure of PQR and the measure of RQS, equals the big angle, PQS. The second part is the converse of the first. So if the measure of PQR plus the measure of angle RQS equals the measure of PQS, then R is in the interior of the angle. So for our picture, we've got our angle PQS. We're going to put R in the interior somewhere. It could be anywhere. I'm going to connect them to make a ray. And then we have this first angle and the second angle here. And if we add those 2 together, it equals the whole angle. So out to the right again, I'm going to do the same thing I did for segment addition. I'm going to write the 2 smaller angles add to the whole. Okay? And that's another idea. Both of those are ideas we've already talked about, postulate 2.9 and postulate 2.11. Alright, now let's go on to the theorems. Locate those on your theorem sheet. Okay, they're in a different spot than the postulates, so make sure you find it. First one, theorem 2.2, says, is segment congruence? And it says, congruence of segments is reflexive, symmetric, and transitive. And we've seen those words before. We used them in our proofs, in the algebraic proofs. Reflexive, remember, that was our mirror, where it's the same on both sides. Symmetric, we said switch, because they can switch places around an equal side. And transitive, we called that the middleman, because the 2 in the middle should be the same. Now there's 3 parts to this. They're all really easy to fill in, because all we're going to do is put congruent signs between them. AB is congruent to AB, that's the reflexive property. The second one. If AB is congruent to CD, then according to the symmetric property, I could have CD is congruent to AB. They've switched places around the congruent sign. The last part, if AB is congruent to CD and CD is congruent to EF, notice the 2 there are the same in the middle part's CD on both, then AB is congruent to EF. We got rid of the middleman part of it. And that's what theorem 2.2 is. It just states that those properties for segments, the reflexive, symmetric, and transitive, all work for segment congruence. Theorem 2.3 is the supplement theorem, and it says if two angles form a line, then they are supplementary angles. Alright, so if I've got two angles here, here's my first angle, angle 1, and then I have angle 2, and together they make a line, then they're supplementary angles. And we've talked about this in class before. Okay, angle 1 then plus angle 2 would have to be 180 degrees because there's 180 degrees in a line. And that's what the supplement theorem is. Something we've already talked about again. It's just if these two angles make a line, then they're supplementary angles. Theorem 2.4, similar idea to 2.3. It's the complement theorem. It says if the non-adjacent sides of two adjacent angles, okay, that means the sides that aren't in common, the ones that they don't share. Okay, so the two sides of the angles that they don't share form a right angle, then the angles are complementary, which means they add to 90. So if we're going to look at our picture here, we've got two adjacent angles. Notice they share this side. They share a side here. And the non-adjacent sides, okay, I'm going to write non-ADJ for non-adjacent. Those two sides, they make a right angle. Then these two angles, angle 1 and angle 2, are complementary, which means angle 1 plus angle 2 equals 90. That's what this theorem says. I'll read it again and we'll go through it one more time. If the non-adjacent sides of two adjacent angles form a right angle, then the angles are complementary angles. Okay, so our non-adjacent sides, again, the outer sides, they make a right angle, and we put the square in the middle inside the angle to denote that. If that makes a right angle, then the two angles are complementary. Now, Theorem 2.5 is the angle congruence theorem. It's very similar to the segment congruence one. It says that congruence of angles is reflexive, symmetric, and transitive. Remember, reflexive means the mirror, it's the same on both sides. Symmetric, they can switch places around the equal sign or the congruent sign in this case. So for the second part, if angle 1 is congruent to angle 2, then they can switch places, and we can say angle 2 is congruent to angle 1. And then the third part, the transitive property, the middle pieces should be the same. Okay, if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, notice angle 2 is in the middle, then angle 1 is congruent to angle 3. We can get rid of the middleman. And that's all this theorem says. It's that those three properties hold true for angles, just like they do for segments. Theorem 2.6. Angles supplementary to the same angle or to congruent angles are congruent. Okay? What this means, let's say that angle 2 here is 50 degrees. Notice angle 1 and angle 2, they make a straight line. Since they make a straight line, I can figure out angle 1 by doing 180 minus 50, and I get 130 degrees. So there's angle 1. Now angle 2 and angle 3, they also make a straight line. So to figure out angle 3, I would do 180 minus 50, and I get 130. And that's all this theorem says, is that since angle 1 and angle 3 are both supplementary to angle 2, then angle 1 and angle 3 have the same measure. They're congruent. I'm going to mark them congruent. Put those curves with the lines on them. Okay, and we showed that with numbers here. We showed it with 130. I could put any number in there for angle 2. And any time that I would subtract it from 180, I would get angle 1, and then I'd subtract it again from 180 to get angle 3. 1 and 3 will always be congruent. Now, Theorem 2.7 is the same idea, except it deals with right angles. It says angles complementary to the same angle or to congruent angles are congruent. We're going to do the same thing we did on Theorem 2.6. Let's put a number in there for angle 2. Let's make it 65 degrees. Notice that we've got right angles down here in the corner. So angle 1 and angle 2, they make a right angle. They're complementary. Angle 2 and angle 3 make a right angle. They're complementary. So to figure out angle 1, it'd be 90 minus 65. We get 25. To do angle 3, we do the same thing. 90 minus 65, and we get 25. Because they both make right angles, so we're going to subtract them from 90. Notice angle 3 and angle 1 are the same again. Okay, same idea. They're congruent. Mark it with 2 this time. They're congruent to each other because they are complementary to the same angle. Both of them are complementary to angle 2. Alright, let's go on. A couple more theorems here. Theorem 2.8. This one is important. You will use this a lot. Okay, so I'd put a star by it. It is the vertical angle theorem, and it's something we've already talked about. Now, you could abbreviate that VAT if you wanted, VAT. Usually we call it the vertical angle theorem or VAT. We won't give me Theorem 2.8 because it's got a specific name here, the vertical angle theorem. It says if two angles are vertical angles, then they are congruent. Now remember, vertical angles, we look for that X shape where the lines cross, and then it's the angles across from each other. Okay, so in our picture over here, angles 1 and 3 are a pair of vertical angles. And according to this theorem, angle 1 is congruent to angle 3. Now we got another pair, angles 2 and 4. They are across from each other in our X. So we could say angle 2 is congruent to angle 4. You use this theorem a lot. That's why we put the star by it. Okay, and again, it's something we've already talked about. So make sure you understand and you can remember that it's the vertical angle theorem now. That's what we're calling this property. Theorem 2.9 says perpendicular lines intersect to form 4 right angles. Now we've talked about perpendicular already. Perpendicular, we put that corner down, or that box down there in the corner, shows that when they intersect they make a 90-degree angle. So this first angle here is 90 degrees. Now notice the one next to it over here, they share a side and they have a straight line between them, which means they're supplementary. So I could figure out its measure by doing 180 minus 90, and 180 minus 90 is 90 degrees. So this one's also a right angle. We could keep going around. These two, straight line right here, okay, they're supplementary. 180 minus 90 is 90. So there's a third right angle. One more. These two angles, the bottom two, make a straight line right here. 180 minus 90 is 90. So there's our fourth right angle. Okay, so according to this theorem, and this is what we just showed here, when lines are perpendicular, you get 4 right 90-degree angles. Theorem 2.10 says all right angles are congruent, and there's no picture for this one. Okay, but this makes sense because every right angle has to be 90 degrees, and since they're all the same, they're all congruent. They all equal the same measure because every right angle has to be 90 degrees. Theorem 2.11 says perpendicular lines form congruent adjacent angles. Now remember, adjacent means next to each other. So these angles next to each other are congruent. And we've already talked about in Theorem 2.9 that when they're perpendicular like that, all 4 of these are right angles. Now since we talked in 2.10 that all right angles are congruent, all of these angles are congruent to each other. And that's what this theorem says, that the ones next to each other are congruent. The ones adjacent. So these two up top, these two over here are congruent, these two on the bottom are congruent, these two on the right are congruent. That's what this theorem says. Next one, Theorem 2.12. It says if two angles are congruent, and supplementary. Okay, so we get two things going on here. Congruent, which would mean they're equal, and supplementary means they make a straight line, then each angle is a right angle. So these two have to be congruent first of all, and they need to make a straight line. They need to be 180. Okay, now if they're congruent, we would cut 180 in half because both of them need to be the same, and we get 90 degrees, which means each one of these would have to be a right angle. And that's what we just proved here. That's Theorem 2.12. If two angles are congruent and supplementary, then each angle is a right angle. Last one, Theorem 2.13. If two congruent angles form a linear pair, then they are right angles. Okay? So if two angles are congruent, let's mark that first. Two angles are congruent, and they make a linear pair, which means they make a straight line. Then they are right angles. Now, we're going to use the same idea we did on 2.12. Okay, straight line has 180 degrees in it, and since the angles are congruent, we cut it in half, which means each one would have to be 90, or a right angle. And that's what we've just shown there. Okay? If they're two congruent angles and they form a linear pair or a straight line, then they are right angles. And those are all of your theorems and postulates for sections 2.7 and 2.8. Make sure that they are all filled out on your sheet and that you have pictures for everyone, and only write down what we've copied down in our notes here. Anything else you cannot have on that sheet. Alright, we'll go over the rest of them in class tomorrow, and we're going to start proofs. So make sure you understand them, and if you have questions over any of those, you ask them in class tomorrow.